A very good day to everyone. My name is Gladys, currently a final year student studying in the Chemical Engineering course. Today, I would like to present on my final year research project, which is the studies on the field properties of Sarawakian brown coals for biomass coal firing. My supervisors for this research project are IR Dr. Jing, Professor Dr. Jaka Sunarso, and Jason Pei. With the increase in the population and rapid development worldwide, the world's energy consumption has been increased rapidly and is estimated to increase up to 28% by 2040. As now, more than 90% of the power generation are from fossil fuel-based sources, especially coals. Increase in the utilization of coals will be seen depending on the increase of energy consumption. However, coals are widely known as the main factor for the emissions of greenhouse gases such as carbon dioxide, leading to global warming and climate change. Hence, it is crucial for governments to highlight in improving the country's emission reduction and fuel safe strategies by shifting towards renewable energy sources such as biomass. However, shifting of coals to biomass cannot be done overnight. Furthermore, coals are still very much preferred by industry stakeholders as it generates more power compared to biomass, thus resulting in the existence of co-feeding which coal and biomass are blended as a fuel for power generation. This leads to research on co-mixing of coals and biomass, which is done by many researchers from different regions. In this research, coal combustion is conducted to determine the combustion characteristics of coal blends. Sarawak is blessed with abundance of resources such as hydropower and natural energy resources, especially coals. The state also holds a goal of achieving sustainable growth and prosperity to become a powerhouse in Southeast Asia, providing the state and other regions with affordable and reliable renewable energy. This results in the potential application of co-feeding into the power generation industries, such as the coal-fired power plant in Sarawak. However, up to now, there are limited knowledge on Sarawakian brown coals, where not much research on Sarawakian brown coals can be found. Thus, the main problem to be addressed in this research project can be the inadequate knowledge and understanding on Sarawakian brown coal. Furthermore, the effects of changes in heating rates and blending ratios on the thermochemical behavior is proposed as the problem to be solved for the determination of optimum operating parameters for an effective power generation. With the problem stated, the aim of this research project will be to determine the potential of Sarawakian brown coal for coal firing application. To achieve the aim of this project, several objectives are proposed, which are to identify the main analysis required for coal sample profiling, to analyze coal combustion, and determine the significant effects of heating rates and blending ratios on coal combustion. Coals are found in many regions, with more than 1 trillion tons of coals are owned by the global coal reserves, which United States and China being the largest reserves, possesses about 23% and 11% respectively. Coals in Malaysia are located in 3 geographical districts, namely Peninsular Malaysia, Sabah, and Sarawak, with Sarawak owning the largest coal resources of 80.7%. Coals can be classified into 4 ranks, which are anthracite, bituminous, subbituminous, and lignite. Anthracite, also known as hard coal, is the highest rank among all, whereas lignite, also called as brown coal, is the lowest rank. There are various characterization analyses, which each analysis determines different characteristics of sample. proximate and ultimate analysis are the most common analysis, where proximate analysis determines the fixed carbon, ash, and volatile contents of coal, whereas ultimate analysis determines the weight percentage of carbon, hydrogen, nitrogen, and sulfur. Oxygen content will be determined by difference. As coals are combustible, it is essential to know its heating values, hence calorific analysis kicks in. Textural, structural, and chemical properties of samples can be determined by several analyses such as Fourier transform infrared spectroscopy (FTIR), scanning electron microscopy (SEM), X-ray diffraction (XRD), and others. However, due to the limitation of financial support and limitation of lab equipment, many analyses will not be conducted. Thus, the main analysis to be done in this research project narrowed down to these four analyses, which are proximate analysis, ultimate analysis, FTIR, and calorific analysis, where samples will be outsourced to conduct ultimate analysis. The outcomes of this analysis can be linked to Van equivalent diagram, a plot developed to characterize complex samples with hydrogen-carbon atomic ratio as a function to oxygen-carbon atomic ratio. Hydrogen-carbon and oxygen-carbon atomic ratio can be determined through ultimate analysis. Hence, we are able to characterize our samples by knowing where it is positioned in the comparison with other resources. Combustion can be done in several techniques such as thermogravimetric analysis, mass spectrometer analysis, fluidized bed reactor, and tube reactor, where thermogravimetric analysis (TGA) is the most used technique among all. TGA is recommended as it provides variety of data, including the combustion characteristics parameters that produces the TG-DTG curves. Combustion kinetic parameter will also be obtained through weight loss curves, which kinetic analysis will be conducted for the investigation of combustion mechanism of coals. As the final year research project will be conducted throughout the year, future work on this research project is planned. With the collected experimental procedures from past research, trial runs on these experiments will be conducted to familiarize on the procedures and to check whether it is suitable to be conducted in our lab. Furthermore, trial runs also helps to brush up our lab work skills in obtaining accurate and consistent data. After trial runs are completed, experiments will then be conducted and data collected will be analyzed for further report writing in the second semester. After finalizing the research plan, calorific analysis was conducted beforehand as it is the simplest analysis among all. There are two brown coal samples, namely BEM and SCR, where the calorific value is determined using bomb calorimeter. The analysis was repeated twice for each sample, and the average calorific value obtained are 17.408 megajoule per kilogram and 21.105 megajoule per kilogram respectively. Residues were observed after the analysis was completed, where BEM contained more residues compared to SCR. The QR code presented here is the reference used in preparing this poster. Not to forget, I would like to thank all my supervisors and lab technicians involved for the guidance throughout the semester. That's all for my presentation, and thank you everyone for listening.